Hi, this is Shelley Kraft. We're coming to you live on SNNLive. We're at the BioMaryland booth at the Bio International Conference in Chicago 2013. I have with me Dr. Alan Faden of Resolution BioAnalytics. We're going to get analytical in a minute. It's a private company. Welcome to SNNLive.
Thank you very much, Shelley. Thank you for having me.
So fill me in on Resolution BioAnalytics.
Well, Resolution BioAnalytics is an interesting company. It started as an accident. The accident was meeting up with my old high school classmate 40 years later at a reunion. He turns out to be one of the more famous applied mathematicians in the United States, a full professor at the age of 26 at the University of Maryland, as a matter of fact. And we regained our friendship, and we started to explore common interests. He had begun to work in applied biomedical areas to make predictions about things like how blood flow works and so on. And we talked about the fact that one of the big problems in medicine was the inability to digest the vast amounts of data that came in every second, fractions of a second, in the intensive care unit type setting. And the question was, how can you digest this data in real time and make predictions that could affect medical treatment? And so out of that grew a dialogue on how we could work together to develop this. And it turned out fortuitously that Larry Goldstein, who is the name of the mathematician's son, is a very well-known developer of software for Microsoft Research. And in fact has developed a new area of mathematics to analyze large streaming data, not for biomedicine, but for things like manufacturing, the stock market, and the like. And so our company will be working with them, with having a relationship ultimately with Jonathan Goldstein and the company, and ideally Microsoft Research, to develop essentially a connection novel software application to allow us to take information in real time in the intensive care unit setting. We'll be working with the University of Maryland, specifically head injured patients in the intensive care setting, from data that has been collected over the last several years in order to optimize the new mathematical applications and then use it to make predictions in real time that should be able to affect outcome. So our goal is to give the practicing physician another 30 to 60 minutes warning time when a bad event will occur, so that that person can intervene, so that medicine can intervene and make a difference in outcome.
I understand. And it sounds to me like there's now an algorithm based on how you come into an event to determine what could happen when you are in a traumatic event. Am I correct?
Correct, but the applications are actually much broader. We're using trauma as an example because they're well-defined outcomes and bad events. But ultimately, this could be applied to the normal operating room setting. Imagine an anesthesiologist that had an extra minute to 2 minutes warning for a bad cardiorespiratory event.
That's a long time in an operating room.
Long time in an operating room. Or imagine in the intensive care unit setting broadly, the ability to have access to the meaning of these vast quantities of data that we now really can only look at in snapshot fashion.
I think as personalized medicine moves forward, and it's almost, I love hearing Junior Goldstein involved, because those younger people have so much training and have done so much in the area of software that one day, we'll have knowing what's going to happen to us next, and we can treat it before it happens. Am I going in the right direction, Doctor?
You're going in the right direction. It's interesting because one of the jokes has been, given how bright the father is, do you think the son's brighter? And I said, well, probably yes. But it's a remarkable.
He may see this.
No, he does see. The father actually sees this and is very proud of his son. But it's a remarkable because I think things come together sometimes fortuitously, and this was an example of a friendship being reestablished, finding another family member who has expertise, and then thinking out of the box to say, can we use the various expertises? In other words, the mathematician's ability to develop a connecting algorithm, which is a missing piece, the adaptation of an existing but new mathematics, basically, and then the access to unique data sets, which is what we have at Maryland, to take data that already exists, where we know what the outcomes are, to go back and refine the algorithms to make predictions, and then go forward in time and make predictions in new patients that affect outcome.
Do you have a website?
Again, under development, and we'll get back to you shortly.
Okay, what's your background?
My background is I'm a neurologist by training, academic neurologist working in brain and spinal cord injury. Spent a lot of my early career working in emergency rooms, even after I was a neurologist. And before that, I was in physics.
So, why Maryland?
Maryland, because I'm at the University of Maryland School of Medicine, where I direct an organized research center that's associated with the Shock Trauma Center and the Department of Anesthesiology. And I'm trying to bring these technologies into the family, and ultimately with a relationship with the university formally and a position in Maryland's biopark.
So this is cutting edge, ladies and gentlemen, I must say. I'm Shelley Kraft. This is SNNLive. This is Dr. Alan Faden. You can Google Resolution BioAnalytics until the website is up, or Google Dr. Alan Faden, find out what he's doing, and it is in Maryland. We're at the BioMaryland booth in Bio International Conference in Chicago 2013. Dr. Faden, Alan, I want to thank you for coming on to SNNLive.
Shelley, thank you so much for having me.
And good luck with all your good work.
Thank you.